Good afternoon, everyone. I will start by acknowledging that we're in the land of the Musqueam people and that you may come from places where ancestral caretakers deserve our recognition, so welcome. And it's the very last TLSS event for the season. The seminar started in 2023. We've had 11 individual presentations and more than 20 individual speakers, actually including instructors and students who now have a platform to tell us about their learning, right? Today, Jörn will close the cycle with the talk very cleverly. A reality check, augmented reality check. Augmented reality assisted technical education at the Center for Advanced Food Processing, a topic so relevant in today's modern education. This hands-on will be hands-on for the first time. We will go with them, so I'm very excited about that. Seminar and demo at CAWP explores how augmented reality can enhance students' training with complex machinery. Acquiring and retaining advanced equipment is essential in a program to ensure students are prepared to lead the industry, but can be challenging when hands-on courses are spread throughout the curriculum. To address this, we're developing interactive guides for equipment setup, maintenance, safety, and troubleshooting, delivered via high-definition AR headsets. The app overlays step-by-step visual instructions directly on the machine, enabling safe and immersive learning by doing. A little bit about Jörn, from cabinetmaker apprenticeship in the mid-90s to an assistant professor of teaching here at the Department of Wood Science. He has built a profound career in wood products design and development. If it's made of wood, Jörn's probably already thought of it. Did you know Parmesan cheese is made of wood? Did you think about that?
Yes.
He's worn many hats within the UBC Wood Science and CAWP family since 2005, serving as student, client manager, and lecturer. After earning an engineering degree in wood science in 2007 and master's in forestry in 2013, and gaining valuable insights from his time at Oregon State's TallWood Design Institute, Jörn now focuses on advancing undergraduate education in wood product design and development at UBC Forestry. I would like to thank everyone who make these events possible. I'll name them actually today. Rob Kozak, initial support, Sarah Gill as well. Tarne Soldati, collaborating with the scheduling with the research seminar series. Karen Horry with the logistics, Michelle Zeng and her team with the technical part, Natasha Carter, Sonia Adlo for the marketing, and also the founding members of the TLSS, Paul Piquel, Sarah Barron, and Caroline Bruce. But I also want to thank past presenters. I see a couple here, Neil, Caroline, Felix, have delighted us with different talks. And so thank you so much. Without you, it wouldn't be possible. And to the audience, this is a pretty good turnout for a summer event. You never know what will happen in June. So this is the second time we have a successful turnout. So thank you so much for coming. And without further ado, all yours. Round of applause for it. Looking at faces here. Yeah. So thanks, Patrick.
Thanks for the introduction.
Some.
Yeah, so today it's going to be a bit different. I'm really excited about it because I'm just going to do probably 10 more than 15 minutes introduction, a little bit about the background of the project, and then we're going to take these down to the shop and do the demo. And depending on timing, if you want to try it out, you're welcome to. We can probably make that happen. We have it set up so that we have basically a screen set up so that you see what the wearers or users see. And so the main thing is going to be down there. So if you're eating, eat up.
No foot in the lab.
No. So I already mentioned it like this, so a brief introduction. And I want to talk a little bit about this. So what is AR, XR, MR, VR, all these abbreviations? And I'll try to make sense of that a little bit. But then again, I'll give a little bit of background. This is just a sneak peek what we're actually trying to do here. So I'll do a little bit, a couple slides, how this all comes together. But then the main thing really is downstairs, the real demo. And again, before we go downstairs, just to make it easier, I'll talk a little bit about the roadmap and year 2 now of the project. And talk about what I hope to accomplish in the next few years. So objectives for developing this step-by-step XR, here it is XR, extended reality training tool for technical education. And just briefly, I think a lot of this seems, or when I started thinking about this, it is kind of common sense maybe, but there is now also a little bit of research that shows that using these kind of technologies, you have increased student engagement and motivation, better knowledge retention, again, especially when it comes to like technical application and hands-on learning, gains in practical skills. We're hoping to also encourage safe practices with it. Again, very important, of course, down in the shop. And what I think is also really important in our program, as you all know, we have a lot of international students, self-paced learning, I think is a really important one. And I don't see this as something that would replace in-person instructions, but it's more kind of like complementary. So it's something where, so the students, somebody shows them, this is how you solve a change on this solve. And they might practice this even with instructors and TAs and so on. But then, and this was said in the introduction, our hands-on courses are kind of like spread out over several years. So then there might be a course a year later. And so now it's like, oh, so you will go ahead and do some problems. I think that's where this can come in. So it's very rapid all and go through it. And kind of at the one days and kind of practice this skill. Yeah, so kind of the story behind it. So the FTIF, Forestry Teaching Innovation Fund, that I think that was almost 4 years ago that I applied for this. And that I think with this technology, back then I kind of pitched the idea that was still with the Microsoft HoloLens. I don't know if you're familiar with it. It's also, at least at this point, pretty outdated headset. And so I got the funding and I started really looking into it, and then turned out Microsoft pretty much ditched it. No more support for it. So then I kind of like put it on ice, and I don't know, 2 years later, I showed up at your office and you're like, oh, I was waiting for you to come back. So anyway, so 2 years later, we started looking into it again more. And I started, and I'll talk about that a little bit, hosting the Emerging Media Lab. And then also through that, we did kind of the first prototypes, got a TLEF that we're actually using right now. So the Emerging Media Lab, right? I don't know if you're all familiar with this, but this really kicked it off for me because it's such a good institution. I guess it's its own standalone department at UBC. And I mean, this is really just copied from their website, right? But it's the mission is to evolve learning by creating tools and techniques using these emerging technologies like VR and so on. What's even more important though is it's student driven. And unfortunately, the students from the EML couldn't make it today. They have another showcase. But that was really, to me, it's just so much fun to work with them. So EML hires students for the summer or even during the term, and they work on your projects. They assign you with a team. And so this is actually the second round for me with EML. And yeah, it's just awesome to work with them. And Lu's actually working with me on this right now as well. So she's going to help out and she's going to help with the demos. And you probably recognize, oh, it's not there anymore. Anna was actually the one in the opening slide. So much appreciated. And again, not not spending too much time on this, but I like the quote that Saeed is talking about here. So that giving students the freedom to experiment, and also that failures during this experimentation can actually become really valuable. And so I kind of like that little quote there. So what is XR, and what about AR, VR, MR? And so these terms, and I'm guilty of that as well, sometimes people use them interchangeably. So XR, extended reality, is really the umbrella term. So it's the umbrella term for all these AR, MR, VR, so augmented reality, mixed reality, and virtual reality. And one way to describe this is kind of the level of immersion. So on the very left side, you have the augmented reality. This is quite often, you might be familiar with the Meta glasses. So these are actually see-through glasses. They have some sensors, and but it's so you see the real world with your own eyes. There's nothing really in between. These are sometimes like semi-see-through, so that other objects or elements can be projected from inside onto the screen, but very important, you see the real world. Then we have mixed reality. So then we're getting into more of a blend and mixed reality, and we'll look at the hardware. This is really like Apple Vision here. This is mixed reality. And so what nowadays happens is we're having cameras, and they capture the real world and then pass it through onto the viewers or the wearers' displays in real time. And again, I'll talk about that a little bit more. And then VR, completely immersed, real world is completely shut off. You're wearing these goggles, all virtual. So as I mentioned, I'll go through this quickly. So you understand the idea behind the different like levels of immersion. And again, so some examples, the AR, a very simple one would be Meta glasses. They're not very advanced actually. This would be a more advanced, the Magically 2. It's a quite advanced headset for augmented reality. And then we have the Apple Vision Pro mixed reality. And I know I call my phone call this a reality check, so augmented reality check. I should really call it and reality check. You told me like I had to come up with some cool title, so there you go. So mixed reality, all nowadays opaque, so not see-through screen, mostly goggles. And this is what I mentioned. You basically, if you put these on, you're completely like right now they're off. I can't see anything. There's a whole array of cameras here, and again, you're welcome to check them out later. And so these cameras capture everything and then display it on your screen. And then the Meta Quest Pro, so that's like pure VR. I should say that this can be used as a pure VR headset as well. So the MR and VR often, it's the same hardware. This is a really interesting one, and that's something I really had to kind of wrap my head around. Okay, so what are all these technologies? What am I trying to do here? And because first, when I approached the Internet Media Lab, I was like, I mean, sure, right? There's the Meta Quest that's like you can get it for $500, should be good, but it's actually not. And one of the main things here is, remember I talked about the mixed reality, the pass-through. So cameras capture and then display it. So the resolution is super important. And again, if we have time, you'll see that. If the resolution is not there, if it's too low, the whole experience just it's pretty much useless. And so that's where this one here comes in, very high resolution. The other one that is important is the FOV, the field of view. This is usually the horizontal. So basically the angular range of what you can see through these goggles. Price, of course. And that is, so this is in US dollars. And so with all that in mind, we kind of like settled on getting the Apple Vision Pro and start experimenting with that. And that's the one that you see here. And then we're gonna demo it.
It's not obvious.
So the first scenario I kind of had in mind, and this goes kind of way back. I don't want to talk about that too much, but the first scenario was, okay, let's say we have our Martin table saw, pretty fancy machine, actually sliding table saw. It's like NC controlled with NC controlled database. There's quite a few steps that you have to take, and you have to kind of do them in the right order to complete this task. And one of the challenges, so this is what you see here now is this recorded 2D process. The first thing we thought we'd do is, okay, so we do object tracking. And for that, you do a 3D scan of the machine. And then the goggles can actually recognize that. What you see here is just a 3D scan, just of the console. So we're talking kind of like this size. And that was already quite complicated to get a proper model of that. And so what we really noticed is it was just a real challenge to 3D scan the entire machine. And we have a lot of moving parts. So then that turned out the whole object tracking was a bit of a no-go. And I was kind of starting to get worried. But then again, EML comes in. Those students, they were just awesome. And so then we're like, okay, let's look about what about image tracking? So then what we do now is, and you see that in the preview here, we basically just use the machine logo as our anchor point. And so what we do now is you reference the goggles, you look at that logo, it references in space, and then from there, with this spatial anchor created, we can now place, for example, these holograms, like a floating arrow or something, just as an offset. So we have the logo at a certain, that's my 000. And then from there, yeah, I can say, okay, now I want to place like a downwards facing arrow, X, 200, Y, and so on. And so it places it in that location. And that worked out really well. That's what we're going with now. This is where it would usually give a demo, but that's what we're going to do after. So just really quick here, we've done some user testing. I think we had 12 participants. Most of you actually participated in the back there, and that was really interesting. So again, I don't want to talk about stats here because we're not quite there, but we had 12 participants, varying skill levels. We had everything from a second-year student who had never done this, so had never done this procedure. They might have received instructions, but have never done it, to grad students who work in the lab, kind of not on a daily basis, but quite often. And what I found really encouraging is that they all finished this entire procedure successfully. And I think that's a pretty big deal. So again, you basically give this to someone, there were no further external instructions, all just through this step-by-step guide. And they just finished the entire procedure. And that was, for me, that was kind of this moment like, okay, we're definitely onto something here. I already talked about that, right? And I think this is something, high motivation and engagement. It's still a fairly new technology, and it's really cool to see students are excited about it. When I was teaching in another class and was looking for participants for this, and I just mentioned it in my class, and instantly everybody's like, I want to try it. What is it? The Apple Vision Pro? Yeah, go. So I think that is something that we can also really harness, right? Like that excitement. But of course, that also, there's also challenges. Interesting is, and you might get to see that as well, we have most of the challenges with operating the headset itself. Maybe, Hanlu, if I can give you this now, and then you can start setting it up. So, and again, you'll see that the operation is with eye tracking. And so there's cameras also on the inside that track your pupils. And usually you have kind of like a controller and you point at something. And this is, you just look at something and that highlights this, and then you just do a gesture like this. So it looks very dorky. So people basically just stand there and do this. And there's a bit of a learning curve there, but that is a typical Apple. Once you understand, it's very intuitive. But to overcome that, it's a bit of a challenge. Glass is not supported. There's just physically not enough space. I get away with it. My prescription is super low, like I can tolerate it without. Voice control recognition can be a challenge. Let's see if we can trigger something here. So if you go, hey Siri, start eye calibration, it would just sometimes not recognize it, right? Even now it doesn't. And so that can be a challenge, especially with students or even myself, where English is not your first language. Somehow it listens to me, but yeah. And really quick roadmap here. So year 2 and 3, we're in year 2 now. We're going to continue the user testing, implementation, and that's something, again, depending on timing, super exciting. We've made a lot of progress here already. So implementation of other machines and how we do this, because we don't want this to be that you always rely on some computer programming skill students to do this. And so we're actually now, we can use the goggles itself to program new machines by then, again, setting up spatial anchors just with gestures. And then we have a web interface where we can then upload instructions and videos. And again, I'll talk about that a little bit more downstairs. But so this is something we're testing now that basically really anybody should be able to use this web interface and just upload new instructions and a new step-by-step guide for other machines. I think we talked about it, right? And this could be really interesting even for other equipment, right? Like lab equipment, there could be opportunities there. Adding other languages shouldn't be too hard. We just haven't had time yet, but certainly on the agenda. Voice control is another one. Perfect example here, right? You actually need your hands to do other things. So voice control would be really good. Right now we're doing the gestures, but ideally when you're doing something, you just want to go, hey Siri, next step. So that's something we're looking into. And hopefully eventually really integrate that with our curriculum and what I mentioned earlier, that as kind of like a support to the in-person instructions. And yeah, that's kind of wrapping it up. Thanks to the team, too bad they can't be here. Amazing team, Hanlu, of course, as well. Big shout out to her. There's some sources here if you're interested. I'm happy to share them with you. But I think at this point, we should go down there. 25 minutes, a little over, but we're good.